Good morning from Florida. Good afternoon over in Europe, and I'm really pleased to be here to present and kick off this great conference. And so my topic is this idea of authoring the digital twin, and I really want to kind of bring you through sort of how I view it, and I'm obviously very pleased that the taxonomy has been picked up by this group, and I think and I'll try to justify why that makes good sense. So I want to basically bring this back to the fact that the conceptual ideal for the digital twin is not a recent thing. It dates back to 2002 when I had created it for Society of Manufacturing Engineering forum in Michigan. And it really didn't even have a name at that time. It was the conceptual ideal for product lifecycle management. But it had been something I'd been working on for a long period of time, is this idea that we were really being able to pull information out of real space and create, in essence, an artifact in virtual space. The gating factor was the technology ability. But if you stop and think about it, we've really had sort of virtual space for as long as there's been humans, but they've been in our mental space. And the problem there is it's not shareable, and our computing capacity to really do complex things is pretty limited. But this was the original perspective of it, and is really sort of continued on. The only difference is I had these sub-virtual spaces underneath the virtual space to call out the fact that we only have one real space, but we have an infinite amount of virtual spaces that we can use in terms of being able to try and experiment to do things that we couldn't do in physical space. In about 2010, when I was at NASA as a consultant, this is the model that got defined, and it's prettier graphics. But the concepts are pretty much the same in terms of the fact that there are really three main components to the digital twin model. There is the physical space and the physical artifacts that we've always had, and that still continues to exist. The new addition here, as you saw from the first slide, is this ability of having a virtual space that turns out to be digital because we have the digital computing capability, and the ability of extracting that information from physical space and creating not only the artifacts in virtual space, but a virtual environment. So the issue of it is that the physical space trumps virtual space every day of the week, because we have to live in the physical space. And so we need an environment that will represent not only the geometry or the image of what it is that we are dealing with in physical space, but also the ability of having the behavioral aspects be modeled and simulated in virtual space. And so in 2010, this was presented in a couple conferences. The third aspect, and I think this is a critical aspect, is the ability of linking these two spaces. So we take data from the physical space and we populate the virtual space with it, but then we can use that information that we can generate through modeling, simulation, behavioral aspects, and we can use that information in physical space. And why? What's the value here? The value is that information is a replacement for wasted resources. Not for the resources I need to do a task, but for anything over and above that. And so even though we can't replace all wasted resources, even if we can replace a fraction of them, we basically can, in essence, be much more productive and effective. If we make our mistakes over on the virtual side, it has very, very little cost compared to making those same mistakes on the physical side. So this whole idea, and why the 21st century is so unique compared to past centuries, is in the 20th century and before, we pretty much had to do all our work over in the physical space. So as soon as we came up with an idea, even though we would have a mental model of it, we had to make it physical, either in sketches or blueprints or physical models or whatever, in order to be able to share that information and in fact enabled to deal with it in any kind of capacity. The 21st century is unique in that it's the first time that we've been able to move that work over into the virtual area and be able to do real, actual, and pretty substantial work. Yes, that started, in the last half of the 20th century, but it's really flowered and primarily even in the last decade. As I said, the digital twin model goes back to 2002. I was pretty much ahead of the curve there, but now we're starting to see from about 2015 on the ability of the technology to be able to implement it. What's kind of interesting about the building aspect of this is that in some industries, notably nuclear reactors or advanced aircraft or spacecraft or even complex medical devices, the digital twin is the ability of being able to create new kind of products that we couldn't create before in terms of scale and scope. Where the building industry is different is that for millennia, the building industry has been basically doing things at a pretty massive scale, from the pyramids to the Greek temples to the Roman era. And if any of you've gone to the Parthenon, I mean, these are sort of amazing kind of buildings of scale that we don't see in kind of other products. You move into the churches of the Middle Ages. I mean, and look what Notre Dame is, and the ability of being able to recreate Notre Dame because we created digital twins of it is pretty amazing. And then finally, the skyscrapers of today. So clearly we could do scale before. So what's the advantage here? The advantage is going to be the fact that the use of resources is going to be a lot less, and the ability of doing more quality things, I think, is going to be fairly substantial. And so this is sort of the value of the digital twin model, is being able to move work into the virtual era and be able to, in essence, reduce our costs and produce more quality things than we have in the past. The kind of issue for the industry as a whole is there will be adopters of this, and in essence, if you don't move into this era, you will not be competitive. And so the issue here is not that, gee, this is nice to have and I'm going to get some pretty cool models and being able to do some 3D stuff, is the ability of the adopters to reduce costs, time to completion, and have a better focus in the buildings and things that have been done in terms of being able to manage this better are going to be substantially different in terms of resource usage in the digital twin era than not. So the choice is that, do you adopt this and be competitive, or do you not? And in essence, you are going to be at a severe disadvantage, if not go out of business. So I want to sort of talk about the digital twin types, because this is a taxonomy that Eduardo mentioned. And I think the key thing here is the fact that it is important that this framework exists across the entire product lifecycle. And in the past, we have been fairly siloed in terms of the engineering, architecture, and design, existed, and then it was thrown over the wall to the builders to go build it in either manufacturing or facilities, and then they turned that over to the support people. And in essence, these were very, very siloed kind of situations in the fact that information was not shared very readily. So the types of digital twins that I have is the first one is the prototypical digital twin, which means, as you can see sort of from this image, that it takes shape over time. And so we come up with an idea first, and then we want to go realize that and in essence build it. Now in buildings, there's a uniqueness to buildings, although quite frankly, one of the capabilities of why we can build the scale we can build is a standardization, obviously, in terms of being able to do that. and I guess that the architect Geary doesn't fall into that category, but pretty much other buildings do in terms of being able to have some sort of standardization. These are all the products that we can make. And so the more work we can do here in terms of moving that work virtually is the more time and money that we can save. We then move into what I call the digital twin instance. And this is actually what did we build? And so these are the products, all the products that are made. And our focus here is the fact that we now want to have a digital twin. In the digital twin prototypical view, we can use virtual reality in order to walk through buildings that we have never, that really don't exist. When we get into the digital twin instance, we need to think about, how did we sensor this stuff so that we can have the information about how this building was made and how it's performing in order to be able to do a better job in terms of both reducing cost and improving quality for its occupants. The final category, and this sort of came a little bit later in my thinking about it, is a digital twin aggregate. And that is, if I can collect all this information about the things that I've made and be able to then correlate it with outcomes, I can do such things as, for example, predict elevator maintenance, HVAC performance, where the occupants are going to be in a building at a particular time in order to be able to do energy management. And so the more information that I can have across a wider range of facilities is going to be able to help me. Now, when I start to look at different units of analysis in terms of subparts of buildings, cities, the ability of building that up and being able to have ontologies that are going to drive this is really going to be an interesting aspect. And there's a fair amount of work, in fact, a lot of work that needs to be done in this particular area. This is a slide from an ARUP digital twin brochure or paper they did. And the focus here was the idea that what are we going to look at in terms of driving the digital twin? And sort of the two aspects that I kind of highlight is the technology is a huge driver of this, and there's no question about that. But culture is going to have to change. And again, so the advantage that the building industry has is they have millennia of how we have thought about building structures and even the cities that they're involved with. But the drawback of that is now that's an ingrained culture, and the culture is going to change in terms of how we have to think about going about in terms of architecting, designing, building, and then being able to support these facilities and how they are going to integrate across a range of not only structures that are like them, but also fitting into the ecosystem of which they're always a part of. And so while we focus a lot on the technology, one of my big concerns and focuses is culture. How do we basically train people to think about it? Because you're going to think differently about these sorts of things. I want to kind of show why this is an enabling in modeling and simulation, and as we bring artificial intelligence into play. And by the way, my issue with artificial intelligence is if you start to have autonomy in facilities without a digital twin, the probability of having a catastrophic event probably goes up exponentially. And so you want digital twins of your facilities, especially if you start to produce intelligence. But if you look at kind of, this is Moore's law that hopefully you've heard about, but this is the idea that every 18 months we double the number of transistors on a chip, and this is a proxy for the fact of how much computing power that we have. And so when I was involved early in the computing industry, you can see we didn't have much in terms of the way of transistors on a chip. But today we passed 54 billion transistors on a chip. And so if this was a regular curve and not a logarithmic curve, you would see the fact that we have reached the inflection point and we are going straight up. So the amount of computing capability that we're going to have to drive technology is going to be phenomenal. And in point of fact, my sort of back of the envelope predictions is by 2030, we're going to go from this 54 billion to 7 trillion, which is a 128 times increase. And by 2040, 885 trillion transistors on a chip, which leads to a 16,000 times increase. So one of my kind of focus points is the fact that we need to be not thinking about what kind of capabilities do we have today, but what are we going to have in the near future in order to be able to think about the sorts of research and focus that we need to have in terms of being able to develop that. So again, when we start to look at culture, there are a lot of implications about it, but we're going to go from physical siloed work to virtual work, which means that this whole thing about each group having their own information and not sharing it has got to basically be broken down. And so we're moving from a functional perspective of work to a product-centric perspective. And so we want to populate and consume the same informational base, irrespective of where we are in the product lifecycle, because quite frankly, that's going to be able to allow us to use this information in order to replace wasted resources and to sort of do two things. One is certainly the time and labor that it takes to do it, but also the amount of clock time, which is never recoverable in terms of that. The other aspect is that we have, and I don't think we've sort of appreciated it, the rise of digital natives. And so the workforce that's coming into play only thinks about these things in how they are in terms of digital. They have been born in this area. I mean, one of the things I get is who's going to train them to do these sorts of things. They instinctively know that. A few years back, I had a young granddaughter. She's about 3 years old, and she was a digital native, and she had a magazine, and she's taking the magazine picture and trying to make it bigger. Okay, it's not working for her. She's not happy about that. And so we have digital natives that are coming into play here that I think are sort of critical in understanding that. So it isn't a matter of, should we adopt this? We're going to have to adopt it in order to be able to have our workforce that is coming into play be able to be productive and do the innovative and things that they have been done. On the other hand, they don't have the experience that the older generation has, and so we're going to have to basically integrate, the experience that the older generation who are used to, who as Eduardo said, never thought about 3D models or this sort of virtuality, and be able to in essence take the best of both worlds for respect to that. So I just sort of want to kind of finish this and talk about how this is evolving and what is our focus in terms of the idea of the digital twin evolution and where we're going with it. And so if I look at the y-axis as being the information evolution, meaning that it's going to be the more complex and defined information. And so those are my ontologies and taxonomies and integrations. And then moving from the physical world to the virtual world.
Michael,
yes.
1 minute.
Yes, I'll finish.
Thank you.
And so we have traditional methods that we've had in the past, which were paper-based and blueprint-based. Transitional, where we're moving into the virtual world that has occurred. Conceptual, which I think we're in right now, which is the idea we have of the digital twin, and we're focused on that whole idea. We're going to replication, where we connect the two together and have this focus on this. And then finally, this whole idea of predicting the future with digital twins. And so the ability of being able to take the information from today, in essence, have a crystal ball into the future. And with that, I'm like to thank you for the invitation and turn it back over.